So we're
I agree
running
with
this
Christian.
problem. Consider atoms in the following element. Assume that the atoms are in the ground state.
SCA what? GA?
SBBR. Okay. So let's see here.
Isn't it GA?
Ben, what do you think? Huh? GA? Oliver, what do you think?
Whichever one of those is one of the alkali metals.
Okay, so
I think it's GA as well.
none of these are alkali metals.
Well, it's in column 13, GA.
So
it
Well,
has,
isn't the definition of an alkali metal like something with only one electron in its highest energy level?
that is, it's in its valence, in its valence shell.
So what's the difference?
So the valence, your valence shell is not the same as your energy sublevel. Your energy sub, you can have a higher energy sublevel in the same shell. So the highest energy sublevel for,
Oh, are those like SPDF?
yes.
Got it.
So we're not looking at the valence electrons. We're looking at the sublevels, which is S, P, D, F, G, H.
So if there's no alkali metals, then that would be something in column 13 or column 3.
Exactly. Yep. Which, if we look at our periodic table, so
none of them are in column 3.
So it could be here, or it could be here, or it could be here. Okay?
Or it could be with the lanthanides and actinides.
You could go down here, but generally in chemistry we don't mess with these a lot because, well, there's an obvious reason, because they're extremely rare, and the only time that you really start to mess with it is if when you get into nuclear chemistry with like uranium and palladium and thorium and stuff. Okay. So are we all in agreement that it is Ga?
Yes.
Gallium. Okay. So question 8, gallium. So let me pull up really quick. If you're feeling a little bit confused about how that works, sublevels. Why do none of these work? Okay. That is a really confusing chart. How about this one? This chart makes more sense. So if I pull this up here, so there's energy level 1, energy level 2. So when you talk about an energy level, that is the shell, okay? That's how many electrons can fit in a single shell. A sublevel, you only have 2 electrons in each sublevel. Well, in these two. And then in the S sublevels, you only have 2. In the P sublevels, you have 6. In the D sublevels, you have 10.
And that's because there's it's like 5 and 7. It's like 5 what is it? 5 shells? I don't know. 5 something and then 7 something, because you can have 2 electrons per shell or whatever.
Okay, so let's look at it. Okay, let's look at at this, all right? So if we, we're going to make this small, maybe. If I can do it. Wait, what? Okay, so if we look at this, so energy level 1, sublevel 1s, we have 1 electron, 2 electrons. Okay? Energy level 2, 2s, 1, 2. Right? And then 2p, 1, 2, 3, 4, 5, 6.
So is there a hard border for these energy sublevels? Because it seems kind of strange to me that like gallium would get it.
Would get what?
Well, I mean, like we were talking about moving aluminum and boron the other day over to column 3. So it seems weird, like kind of arbitrary that gallium would be in one sublevel. Are these arbitrary at all, or is there
Not,
a specific?
not really. But the thing is, like, you could put boron and aluminum over here if your periodic table stopped at 18. Or rather, if it stopped at 20. 21 introduces a new sublevel. It introduces a whole new level of electrons, which is level 3.
Well, I have a periodic table here with me that is made a little bit different than yours, and it makes it a bit more confusing.
Okay, well, so gallium is here because it has more protons than zinc, but it is in this. It has the same energy sublevel as aluminum.
So what is an energy sublevel then?
The energy
Like
sublevel,
on a chemical level?
the energy sublevel is how much energy the electrons have in a certain orbital.
And it just changes suddenly from zinc to gallium?
Yeah, well, it changes from zinc to gallium because zinc holds on to its electrons. Zinc has, so the electron configuration of zinc is, we can just start from argon, right? Is argon, let's see here, 3s2, 3p, 6,
Yeah, but why does it
Sorry,
change from S to P right there?
What?
What actually changes chemically from
The
S to P?
The ionization energy.
So for manganese and iron,
Gallium pulls more on its step. So,
but copper and zinc don't.
Copper and zinc, yeah, because the electrons are in a different sublevel. Yeah, I don't know. It's hard to explain exactly how it all works because I don't understand it quite enough to the level that you want me to explain it to. So don't hate me. Cool.
Okay, I'm just going to disagree with the periodic table and move on.
Well, take it up with Mendeleev, okay? Take it up with Mendeleev. But do we see why the sublevels work the way that they do? And why the periodic table is laid out the way that it is? Okay?
I could use a little clarification.
Could use a clarification.
Yeah.
So if you're
like a summary.
If you're confused about the electron configuration of an element, is that what you're confused on? Yeah.
No, I'm confused about the way that periodic table is laid out. like I just want like an in short, like because that was a lot of information.
Yeah. 1s here.
Uh-huh.
Okay. 2s here.
Next one's 3s, and
Two
then on the
no,
2p. Okay.
3s. 3p. Okay. 3d. Wait. Yeah, wait. 2s here.
Yeah,
2p is here. 3s. 3p. Wouldn't this be 4s? This
Yeah,
would be
that's what I
4s.
thought.
Oh, yeah. 3D here. There's 10. Right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Does that make sense? So S, P, D.
Okay. I remember there being like a couple more.
There are. There is
F.
F, which is down here.
Mm-hmm.
Yeah.
Are
Okay.
the noble gases?
So we're not going to worry about those.
What about the noble gases?
They're part of P, besides helium.
BRP, yes.
Cool. Move helium.
SPD. I can remember that like STD.
There you go. Okay. Can we number which one? 11. Okay. All right. When free chlorine atoms encounter ozone molecules in the upper atmosphere, the following reaction mechanism is proposed to occur. And we can go through this if we need to, but I don't think that we really need to, and I'll tell you why. The proposed mechanism can be written in a more general form as shown above. Species other than chlorine also decompose ozone through the same mechanism. Which of the following chemical species is most likely to decompose ozone in the upper atmosphere through the above mechanism? So what are we looking for here? What are we looking for? Mm-hmm.
What did he say?
So these are not elements. These are molecules. What? Yeah, you can find these as molecules in the atmosphere. This is the primary constituent of the atmosphere, molecular nitrogen. But I think what's tough about this question is they give you all of this information.
Yeah, that's what's tripping
Okay?
me up, to be honest.
This is daunting. Okay? But when Cl, this is just an atom of chlorine. When Cl encounters ozone, it decomposes it. What do we know about the periodic table about things that behave similarly?
They're generally in the same place.
In the same, what do you mean by place?
Row.
Yeah,
Column.
either same row or column.
Okay, row is a red herring.
Oh,
Row
right.
across,
Same
right?
column.
Row is across and column is
Row
down.
is across, column
Yeah.
is up and down.
Oh, okay, so it's the same column.
If it's in the
Yeah,
same,
just think of columns. You know,
Yeah.
the up and down
Columns
ones.
as in things like that hold up buildings.
Marble columns.
Marble. So we have some possible answers here. The possible answers are helium, bromine, molecular nitrogen, and molecular oxygen. Chlorine and bromine are right next to each other in the same column. This question is designed to make you crap your pants with all of this business.
Remember, we decided it's PG-13 here.
It's PG, as Ben said.
You have to say poop your pants.
Okay, this question is designed to make you nervous just by giving you all this information. It even
Damn it, College Board.
Dang it, College Board. Yeah, exactly. The answer is staring you right in your face. It's in the same column. Bromine decomposes ozone in the same process because it has very similar chemical properties as chlorine. Okay?
What's the question asking?
The question is just asking which one of these is going to replace chlorine in this reaction.
Oh,
Which one of these can easily replace chlorine in this reaction?
okay.
Does that make sense, Christian? It's one of those questions like in Jeopardy when the category in Jeopardy is stupid answers. Right? It's like, this is too simple. I don't feel comfortable with how simple this is. But the simple answer is oftentimes the correct one.
You said elements in the same column.
Elements in the same column have the same chemical properties.
Can we do, I don't remember if it was 4 or 5, but one of those?
The combustion one?
Yes.
Yep.
It might have been 6.
Complete the combustion of a sample of hydrocarbon.
Wait.
So both of these have combustion in them.
Let's do number 5.
Or wait, I guess this one doesn't have combustion in it, but it tells us what the empirical formula is. It's asking, okay, so this is an empirical formula question. CH3O, C2H6O, C3H9O2, C4H12O2. 23-gram sample of the compound contains 12 grams of carbon, 3 grams of hydrogen, and 8 grams of oxygen, which of the following is the empirical formula of the compound. How do we solve this?
Let me explain it in unit terms. Okay, you change the grams to a grams per mole using the little thing on your periodic table. And then, so then you have your moles, and then you just put them together in the empirical formula style. This is much more complicated than it needed to be, but I just wanted to make clear that, you know, the units.
Can I mute someone? Is that an option? Anyway, as I was about to start talking, you need to figure out how many moles of each element you have, and then you need to divide everything else by the smallest number, or is it multiply? I think it's
You're determining the
divide.
percentage.
Yeah.
Yeah,
so
you
you're
just,
gonna
you
divide.
follow the units, Quinn.
Oliver, shut up. Anyway, you divide by the smallest amount of moles, and then you, if you can, you round up. If you can't, then you times it to make the nearest whole number for all of the things.
Okay, so let's do this really quick. Yeah.
The grams of the element over.
So you want to figure out how many moles of each one you have.
Are we dividing it by over 5?
Yes. No. Not Avogadro's number. You're dividing so you figure out the molar mass of each thing. So carbon is what? 12, what is it? 12 per mole, right? And we have 12, so we have 1 mole of carbon. We have 3 moles of hydrogen, and we have half a mole of oxygen, right? So that means that we're just going to look for the thing that has the same ratio. Does that make sense? This number, the 23 grams, is not actually important. Well, yeah, it is important in that this does equal 23, which is important, right? 12 plus 8 plus 3, that's 23. Or 12 plus
23 to me.
Would it be B? So
That's what I think.
would it be B? So let's look at it. Okay, so if we have 1 mole of carbon, we have 3 moles of hydrogen, and we have half a mole of oxygen. Look for that same ratio in the empirical formula, right?
Mm-hmm.
That ratio is 1 to 3 to half, or if we can, then we can just increase it.
Multiply them all by 2, right?
We can multiply them all by 2. It's 2 to 6 to 1.
Right, so it would
2
be
to 6
B.
to 1.
So it's C2H6O1.
Yep. Which is B.
And D would technically be acceptable, but it's not really the empirical formula.
Right. This is the same ratio, but this is the molecular formula, not the empirical formula. It's B. Okay. It may actually not be the molecular formula, but we can determine that this is the correct ratio. And remember that the empirical formula is the ratio, where the smallest number, it has to be divisible by the smallest common denominator. Okay? Are we
Can you
clear
show
on
me
that
how
one?
to get to this quiz?
Show you how to get to this quiz?
Yeah.
Maybe. So, okay. So my thing looks different than yours.
Okay.
So I have assigned the progress check, which is the actual exam. Okay, so you can get there by clicking on progress checks. Or, so this is how you get to the actual exam. At least for me it is. It looks different for teachers than it does for students. I'm doubting that you have the question bank thing. So I don't know how to make this a student view. Progress dashboard, maybe?
Last year, I always went to my AP college board, and every time I logged in, it would take me to my class, and just like.
Yeah, so
assignments.
if you go to your class, there should be an assignment thing. And the practice and the progress check should be the only 2 things that you see.
Okay.
Okay. Again, I can't link to it in the Canvas assignment because I don't have the student interface. I have the teacher interface. So I don't know how I could link it in. If somebody wants to send me the link, or if someone wants to put the link in like a discussion or in a chat on the course, that would be helpful. Or if you just want to send it to me as a chat, then I can link it in for the rest of the students. Okay, did it help you all out to go over those questions?
Yes.
Okay.
Yeah, thank you.
Yeah, no problem. So hopefully the practice exam will get you ready for the actual exam. It should be very similar kinds of problems. There are just fewer of them. Okay?
Cool.
Cool. And this is how I'm going to do it. I'm not going to do a study guide for the tests on this in this class. The study guide is essentially the practice exam. So you're going to you're going to do the practice exam, and then you're going to do the real exam.
Okay.
Okay. I'm going to leave it at that. We can. I'm gonna upload this recording to the YouTube channel, so you can rewatch it. And yeah, so going to stop the recording.